Good morning. In this Unit 4, I will talk about distributions of random variables, mathematical expectation in continuous variables. In the previous video, I already explained the concept of mathematical expectation. So we have a random variable, we define a function of the x, and then mathematical expectation in continuous variables, it is defined according to the following formula. So the expectation of this function is the integration of this function multiplied by the density function. Okay, so the expectation of x, so when this function is x, which is the most simple possible, the expectation of x is the average or the mean, well, the same in discrete distributions. And then I told in the previous video that quite often we will say that the expectation of x is the same as talking about the mean. So in continuous distribution, we have that the mean or the expectation of x is the integration for all the range of values of x multiplied by the density function. But if this function is x minus the average squared, okay, so the expectation of x minus m squared is the variance. So we will say that the variance, okay, so is the integration of x minus m squared multiplied by the density function. Now we will explain some exercises where we apply these formulas. Remember that when we apply the square root, it is the standard deviation. Also, another way to compute the variance that I explained in the previous video and I demonstrated is that the variance is the expectation of x squared minus m squared. This formula applies for discrete and also for continuous distributions. Okay, so let's think about this distribution. So imagine that we have one variable that follows a uniform distribution, okay, uniform because it's horizontal, the density function, between 0 and 10. So as the area below the density function has to be 1, this value is 1 divided by 10. Okay, so we have that the density function is constant, it is 1 divided by 10 between 0 to 10. So now let's compute the average. Okay, so the average by definition, applying the previous formulas, is the integration between 0 and 10 of x multiplied by the density function. So x multiplied by the constant 0.1. So the integration of x is x squared divided by 2, okay, x squared divided by 2, so we apply the rule of Barrow, so we put 10 squared minus 0 squared, well, at the end we get the value 5, which is interesting because this distribution is symmetric, so for any kind of symmetric distribution, the average is the axis of symmetry, so we can check that this condition is fulfilled. Okay, so any kind of symmetric distribution, remember the average is the axis of symmetry. Okay, now let's compute the variance of a uniform distribution between 0 and b. So instead of from 0 and 10, I'm going to be more general and talk about maximum value b. Okay, so we apply the formula. The variance is the integration between 0 to b of x minus m squared multiplied by the density function. This is the general formula. Okay, so the integration of the average is b divided by 2, so x minus the average squared multiplied by the density function, which is a constant, 1 divided by b. Okay, then the integration is this expression power to 3 divided by 3. Okay, so you can see that this is the expression integrated. So we apply the rule of Barrow. This expression is x is substituted by b minus the same expression where x is substituted by 0. Okay, and then we operate here, and at the end we get b squared divided by 12. Okay, so this is interesting because when I will talk later in another video about the uniform distribution, when I talk about the variance, I will explain and I will refer to this formula. Okay. Then, but there is another way. Remember that there were like two formulas to compute the variance. so the expectation of x squared minus the average squared. So let's check if this way is somewhat easier. So the average is b divided by 2, so minus the average squared is here, then plus the integration from 0 to b of x squared multiplied by the density function. Okay, the integration is x power to 3 divided by 3, and then we apply the rule of Barrow. X is equal to b minus x being equal to 0. Okay, so you can see that the mathematical calculation is slightly easier, but at the end we arrive to the same result. Okay, so now I'm going to talk about another example. Let's imagine that we have one variable that follows a triangular distribution between 0 and 10, so that the mode is 0. Okay, so this is the shape of the histogram, something like that. Obviously, it is a skewed distribution, a positively skewed distribution. So it means that the density function has to be like that. Okay, the minimum is 0, the maximum is 10, and the mode means in a histogram the value that the bar reaches the highest value. Okay, so this is the density function. We have to think about the mathematical equation, and so it's the area of the triangle is 1. So we make the product of the base multiplied by the height divided by 2, and then we end up that this value, this maximum value, is 1 divided by 5, 0.2. Okay, then based on this we can derive the mathematical expression of this line. This is not statistics, this is mathematics, but you can check that when x is equal to 10, this becomes 0, and when x is 0, this becomes 1 divided by 5. So the expression is correct. Okay, now calculate the median. Okay, so the median is a value somewhat in between. So the integration between 0 to that median of the density function is going to be 1/2. So we can solve this integration. Okay, this is the integrated expression. Now we apply the rule of Barrow, and then we solve the value of k, which is the median, and at the end we get that the median is 2.93. Okay, but now we can calculate the average by applying mathematical expectation, the formula. Okay, so the integration between 0 to 10 of x multiplied by the density function. Okay, in this case it is a polynomial expression. Okay, this is the integrated polynomial expression. Now here we apply the rule of Barrow. All of this expression is x is substituted by 10 minus all of this expression where x is substituted by 0. And then we make this calculation and we end up with the solution of the average. Okay, then let's discuss a different exercise. So now imagine that we have two random variables that we call x1 and x2. Let's imagine that both follow a uniform distribution between 0 and 10. And imagine that the values are independent, that there's no correlation between them. Okay, then taking into account that their sum follows a triangular distribution, okay, calculate the probability that this sum is less than 5. Good. So we sum, and mathematically it can be demonstrated that if both variables are independent, if they're not correlated, this is the shape of their density function. Okay, well, the area of this triangle has to be 1, so we can demonstrate based on the formula of the area that the height, the maximum value is 1 divided by 10. It is 0.1. Okay, so from 0 to 10, so in this first part, the mathematical expression of the line is this, and then we have the value of 5 here. Okay, so what is this is a calculation. What is the probability that this value is less than 5? This is the integration between 0 to 5 of the density function. Okay, so we make the integration, and that probability is 0.5. 125. So, and now let's think about this. If the values x1 plus x2 less than 5 are selected, okay, so if we focus on the first part, on the first, okay, so thinking about this line, what would be the mean? Okay, now we have to recalculate the density function because we are in a different situation. Now the area from 0 to 10 has to be 1, and so we have to multiply the previous density function by 2. Okay, so now this is the new density function, and now in this case, what would be the mean? Okay, so now the range is 0 from 10, so we make the integration from 0 to 10 of the y multiplied by the new density function. Okay, the integration is the y power to 3. Then we apply the rule of Barrow, the y being equal to 10 minus the y being equal to 0, okay, and then we end up that the solution is 6.66. Okay, well, the variance, as I told you, is the expectation of x minus m squared. Always this is positive and the units are squared. Okay, for any kind of units of the x, the units of the variance are always squared. Okay, so properties of the variance for any kind of distribution. It doesn't matter to be discrete or to be continuous. Okay, so the variance of a constant that multiplies a random variable is that constant squared multiplied by the variance of the x. The variance of a constant plus another constant that multiplies x, okay, so this constant b affects the average, modifies the mean, but it does not modify the dispersion of the data, so that constant b does not appear, and we end up with the same formula, a squared multiplied by the variance of the x. Okay, now imagine that we have a two-dimensional variable where x and y are the two components, so the variance of x plus or minus the y is the variance of the x plus the variance of the y plus or minus 2 times the covariance. Okay, so in this formula, if here we have a plus sign, here it will be a plus. In this formula, if we have a minus, here we will have a minus, but here we always have a plus. Because the variance has to be always positive. Okay. If these values are multiplied by a constant, so we end up that the formula is somewhat more complex. It is a squared multiplied by the variance of the x plus b squared multiplied by the variance of the y plus or minus 2 times the a multiplied by the b multiplied by the covariance between x and y. Okay. Remember that the covariance is this formula. I talked about it in a previous video. The covariance is a measure of the correlation between two variables. If there is an increasing trend, okay, so when I increase the x, the y also tends to increase. We say that two variables are correlated. Okay, so if that correlation is positive, the covariance is positive. If there is a decreasing trend, then the covariance will be negative. Okay, this is the formula when we have a set of n values, but if we have infinite values, the formula can be computed applying expectation with the formula indicated here. Okay, so what happens if x and y are independent? Independent means that there is no correlation between the x and the y. Okay, so in that case, the covariance is 0, and the formula is simplified, so that the variance of a sum of two variables is the sum of the variances, and the variance of x minus y is also the sum of the variances. Okay, so in this case, there's no correlation between x and y. We say that they are independent. Independent means that they're not correlated. Okay, the same formula can be applied in case of summing n variables. Okay, so if instead of 2 I have n, if all of them are mutually independent, so the variance of a sum is the sum of the variances. These formulas will be applied quite often in exercises in this unit. Okay, and also it can be demonstrated that the expectation of a product of two variables which are independent is the product of the expectations. Okay, so now what happens if x and 2 are independent variables with the same distribution? Okay, we can think the following. So imagine that we have x1 plus x2. They are two variables exactly with the same type of distribution, but they are independent. So in mathematics, if we have two things which are equal, we can say that this is 2 multiplied by x. But in the statistics, this is wrong. So we have to be very careful. It is not correct to say that x1 plus x2 is 2 times multiplied by x. No, this is wrong. And now I'm going to demonstrate why not. Okay. So they have the same mean, but look, the variance of x1 plus x2 is the variance of the first plus the variance of the second. If they have the same type of distribution, the variance is the same, so this is 2 multiplied by the variance of the x. But what happens if I have the variance of 2 multiplied by x? The constant becomes squared, so this is 2 squared multiplied by the variance of the x. So this is 4 multiplied by the variance of x, so that you can check that this is different. The result is different. So important. So please remember that this is not correct in statistics. Okay. Now let's think about the following question. Imagine that variable x is the number of calls received in 1 minute. And then we want to study the number of calls received in 1 hour. We can think, well, maybe that new variable is 60 times multiplied by x. Well, no, this is wrong. Again, this is more or less the same concept as before. Okay, so the total number of calls received in 1 hour, what is that? It is the sum of the calls received in the first minute plus the second minute plus the third minute until the minute number 60. This is not the same as taking the number of calls in 1 minute and multiplying by 60. This is different for the reason that I have explained above. Okay, so now let's think about this example. If the variance of the x is 2, what would be the variance of the y? Okay, so the variance of the y, is it 60 times multiplied by, okay, so if we think that the y is 60 times multiplied by x, that would be 60 squared multiplied by the variance of the x, which is 7,200. But this is wrong. What we should do is that the variance of the y is the sum of the variances. Okay, as I told in the previous slide, if we assume that the variables are independent, this is the variance of the first plus the variance of the second. So as the variances are equal, this is 60 times the variance of the x. So this is 60 multiplied by 2, which is 120. So you can check how different it is. So this is the real value, 120, but if we make this wrong calculation, that would be 7,200. So it is much higher, but this is a wrong calculation. Okay, so this calculation, as I told you, is when we assume that they are mutually independent. Okay, now let's think about this question. Imagine that we have the height measured in centimeters and that the variance is 100. So now imagine that we have the height measured in meters. Okay, what would be the variance? Okay, well, this is a question that sometimes we have put in the exams. Well, the variance of the y is the variance of a constant that multiplies x. So this constant becomes squared. Okay, so this constant squared multiplied by the variance, so this is 0.01. That would be the solution. Okay, and here we finish this video about mathematical expectation in continuous variables. Thank you very much for your attention.